Okay, you made it past the first page. Congratulations. Now we're going on to the second one. Find the equation of a line perpendicular to y equals 2x plus 4 and passes through the point 4, 4. Now the word perpendicular is the important point here. That word perpendicular tells me the special rule that gradient 1 times gradient 2 is equal to negative 1. So if I look at my first line here, my gradient for this line is 2. So 2 times, and I'm just going to say m now instead of gradient 2, is equal to negative 1. Now I need to divide both sides by 2. So m is equal to negative a half, because I just divide that by 2, leave it in fraction form. Now if I want to write the equation of my line with this new gradient, y equals negative 1/2 x plus c. I don't know what c is yet, but what I do, I also have been told I've been given another point in my question. Well, I'm going to substitute in this point into my line to try and find the value of c. So we've got that 4 is equal to negative 1/2 times 4 plus c. 4 is the value of y, 4 is the value of x. So 4 equals negative 1/2 times 4 is negative 2 plus c. So 6 is equal to c because I add 2 on both sides there. Add 2. Add 2. So I now know the gradient is negative 1 over 2. I know that c is equal to 6. So the equation of my line is negative 1/2 x plus 6. Now for my next one, it's the exact same steps as the first question. It's the exact same procedure in which we write a line, we plug in a point to find the constant. The only thing that's different is that gradients aren't different for parallel lines. Gradients are the same. So if the gradients are the same for our questions here, then what that does to our line is that instead of changing it, I'm just going to have the same gradient. If this gradient is 2, then my parallel gradient is also 2. And then it's still that plus c. Well, again, I'm just going to plug in a point, and that's going to help me find my value of c. So instead of y, I'm going to write 4. And then instead of x, I'm also going to write 4. So 4 equals 2 times 4, which is 8. So 4 equals 8 plus c. And then I take away 8 from both sides, where negative 4 is equal to c. I know that m is equal to 2 because it's my parallel gradient. I know c is equal to negative 4. So the equation of that line is y equals 2x take 4. And that's your answer for that one there. All right. Moving on. Solving linear equations. Again, we want to try and get all variables onto one side and all numbers onto the other. The problem with my first question with 4a is that I've got variables on both sides, and that's not going to be very helpful for me. So what I need to do is I first need to just get rid of my variable. I need to make sure that I only have variables. So I need to take away 5m first, and take away 5m from here. So 12m take 5m is 7m equals negative 35. Divide both sides by 7. So divide that by 7, that by 7. M equals negative 5. Next question. I need to expand out these brackets first. And then that's going to help me solve my problem. So we've got negative 9m plus 18 equals 27. Next, I need to move my 18 because I've got numbers on both sides. I want 9m to equal something. If it's a plus 18, I take 18 to get rid of it. So negative 9m equals 9. And then I'm just dividing by negative 9 on both sides. So m is equal to negative 1. Now that fraction is the annoying part in that next problem, okay? So I don't want the fraction to be there until last. I don't want to deal with that until last. First step I should do here is to move my 13. If it's a plus 13, I need to remove 13 from both sides. Again, guys, just a reminder, you don't need to do these arrows for the test, okay? The arrows are non-essential. It's just showing you my step-by-step working. So 4d over 3 equals, now 5 take 13 is negative 8. Next up, I'm multiplying both sides by 3. So times that by 3, times that by 3. So 4d equals negative 24. Negative 8 times 3 gets me to negative 24. And now lastly, to find d, I need to divide both sides by 4. So d is equal to negative 6. And that's the answer for that question there. Okay, now you see with this 4d, I'm expanding out both brackets on both sides. Okay, so that's where the tricky part comes with this question. So I need to expand this bracket. I also need to expand that bracket. So 6 times 2x, that gets me 12x. 6 times 1 gets me 6. 5 times 2x is 10x, and 5 times 3 is 15. Again, I want to get all variables on one side of my equal sign. I want to get all numbers on the other side of my equal sign. So from there, what we have to do is we have to move around some things. We have to move my variables first. So let's get rid of the 10x. Let's move 10x over here. So I have to move it on this side as well. 12x take 10x is 2x plus 6 equals 15. Well, then I just have to take away take away 6 on both sides. So if I'm going to get rid of 6, take 6, take 6. 2x is equal to 9. And now just dividing both sides by 2. Because 2x, if it's multiplied by 2, I need to divide by 2. 9 over 2. And now instead of 9 over 2, I could also write 4.5. Both answers would get you full marks. They are the same equivalent amount. Lucky last for this page, okay? Again, it's another expanding the bracket problem. So I'm expanding the 7 to 1 and 2a. 33 equals 7 plus 14a, take away a. Now what I should do first is I should combine all my like terms. Always try and make it as simple as possible before you start moving things around. So I can combine these two, and that's going to give me 13a. That's going to give me 13a. So 33 equals 7 plus 13a. Next step I want to do is I want to move my 7. Because if I've moved my 7, then I can just divide by 13 to get to an answer. So take 7 because it's a positive 7 here. 26 equals 13a. So 2 is equal to a. Because I've divided both sides by 13.